This is the question number 4. A carboxylic acid reacts with an alcohol to produce an ester and water. We know this is a very well-known reaction that an acid, this is an organic acid, reacts with an alcohol, ROH. And when react, it is actually a reversible reaction. And it occurs in presence of acid. And as a result, it produces CH3, C double bond O, and from alcohol, OR group comes here. So this R and this R, that is CH3, I have written here, a particular group. It could be anything else. So while the hydrogen from here and OH from acid combine to form water. But remember that here, although hydrogen is transferred from here to here, but if you will see the actual mechanism in A level, then you will find that this is not acid. This is something else. So by observing this equation, you can't say it acid-base reaction. This is not acid-base reaction. At this level, I cannot explain it to you. Then you will learn it in your higher degree. So a carboxylic acid reacts with an alcohol to produce an ester and water. Under certain conditions, this reaction can be reversed as given here. And as it produces carboxylic acid X. So X is acid, carboxylic acid, while Y is an alcohol. Okay, now what is the question? And one more information that is very important, definitely for some part of the question, that would be, we will see. So deduce the empirical formula of the ester that is here. So first write the molecular formula somewhere in your copy. 4 carbon atoms are there. 3, 3, 6, and 2, 8. 8 hydrogen atoms are there, and 2 oxygen atoms are there. So this is the molecular formula. So its empirical formula, you just divide it by the smallest whole number. If it is divisible, then it is C2H4O. Now name the ester. How can we write the name of an ester? If you see, this is the structure of this ester. I have written it in an open form. Here I told you that this part comes from an alcohol, so definitely this part comes from an alcohol. So, and the part that comes from alcohol, here it is CH3. For writing the name, we write it first. That is 1 carbon, so it is methyl group. But there must be a gap, and we will write the number of carbon atoms, 1, 2, 3. So the basic chain or the parent chain would be prop, prof, because there are 3 carbon atoms. But you can see all the carbon-carbon bonds are single bonds. I'm not talking about carbon-oxygen bond. If all the carbon-carbon bonds are single, then this is a derivative of an alkane. And then we use the suffix of the functional group, and the here functional group is ester, and suffix for ester is oat. So for avoiding two consecutive vowel, we remove e, and we will write here propanoate. Oat is the suffix for ester. So the name of this ester is methyl propanoate. Now name the carboxylic acid and draw its displayed formula. So you can see here, again, I'm telling you the same thing, that this OCH3 part comes from an alcohol and this part from carboxylic acid. So how many carbon are there? 3 carbon atoms. So just like methyl propanoate, it is prop. All the carbon-carbon bonds are single. So it is N, propan, and E would be removed because the suffix for carboxylic acid is oic acid. So propanoic acid. If you want to draw this formula, as they are asking about its displayed formula. Displayed formula, a formula where we should write every bond. We have to show every bond. So first one is the CH3. So at the terminal, carbon is always CH3 because one bond is with other carbon while remaining valences are fulfilled with hydrogen. So next one is CH2, and the next to CH2 is C double bond O. And if it is carboxylic acid, then there would be OH as well. So in this flat formula, OH is also written separately. So this is the displayed formula of carboxylic acid X. Now, complete table 4.1 to show the effect, if any, for each change of condition. So we can see here this reaction is reversible. Remember that esterification reaction is a reversible reaction. So better to put the whole reaction over there with the question so that we can answer easily. So here, now see this reaction to answer this part E. Complete table 4.1 to show the effect, if any, for each change of the condition. Here the change of the condition given here, and here we will write the effect on the concentration of carboxylic acid. Remember that this is carboxylic acid on the product side in this equation. And we have already seen in the question that this is an endothermic reaction. If we say a reversible reaction is endothermic, so it is endothermic in forward direction. So if it is endothermic, then it requires more energy, higher temperature to converting more ester into carboxylic acid. So if we decrease the temperature, so it will also decrease. So the concentration of carboxylic acid will decrease and reaction shift towards left. So ultimately, the concentration of ester would increase, but that is not part of the question. Concentration of ester is decreased. If we decrease the concentration, then again equilibrium shift towards left. So again, it would decrease. More alcohol Y is added. If we add the alcohol here, so definitely the total concentration on product side would increase. So it causes the shift of the equilibrium towards left. And shifting of equilibrium towards left means carboxylic acid and alcohol combine to form more ester. So in this way, again, the concentration of carboxylic acid decreases. And now a catalyst is added. Remember that adding catalyst can make the reaction fast. A reaction may occur with a faster rate. So equilibrium would be achieved earlier, but there would be no effect on position of the uh, equilibrium, or in other words, there would be no change in concentration of acids, base, or product, whatever. So we should write no effect. Now this is the last part of this question. At the beginning of the reaction between the ester and water, no carboxylic acid is present in the mixture. Suggest how the pH of the reaction mixture changes from the start of the reaction until equilibrium is reached. Assume alcohol and esters are neutral. So as we have seen in this equation that initially nothing was there and only carboxylic acid, only the ester and water was there, and uh, both of them are neutral, and as well as alcohol is also neutral. So initially the pH was 7, and we should remember that it should be written in words, not in words. It should be written in number. So the pH is 7, and we should write it like this. But definitely when the reaction start means hydrolysis of ester starts, then there is uh, appreciable amount of carboxylic acid that decreases the pH. As it is acid, so definitely the pH must be lesser than 7. But one more thing that should be remembered, that this carboxylic acid is a weak acid. So the pH of the weak acid do not decline more less than 3. So the pH should be greater than 3, not lesser than 3. It can be 3 or more, and but it must be lesser than 7. So we should write it completely, otherwise you won't get 1 mark for this statement. Okay. Next part is identify the ion that causes the change in pH. So definitely here the ion is only hydrogen ion. Hydrogen ion causes the change in pH. Name the indicator which can be used to follow the change in pH. Remember that you should remember that we use number of indicators in acid-base titration, but those indicators do not uh, reflect any change in pH. They just show the change around a particular pH point. So if we want to observe the pH change, then we use pH paper, which mainly comprises universal indicator. And remember that universal indicator is a mixture of different indicator that show the change in pH at every point. So we use universal indicator. Universal indicator.